Hi, hello everyone. Welcome back to my channel Savvy NX. In class 9 motion chapter, we will learn about an interesting topic about motion graphs. So today we're going to learn about distance time graphs. So before we get into today's video, don't forget to subscribe to my channel and click the bell icon so that you'll get a notification as soon as I upload a video. So now let's get started. So first let's learn about the uses of distance time graphs. So there are like three uses. The first is we can find the nature of motion, we can find the distance, and we can also find the speed of the object. So first let's check out the uniform speed, the distance time graph for uniform speed. First is the uniform speed. So first let's draw the x-axis and the y-axis. So dependent quantities always lie on the y-axis, and since distance is a dependent quantity, it lies here, and independent quantities such as time lie in the x-axis. So this is the outline of the graph, and the graph of the uniform speed is always a straight line. This is because it travels equal distances in equal intervals of time. And since it's a straight line, the nature of motion is uniform. So next is we can find the distance. How would I take a point such as point X and need to find the distance traveled at this particular time? So for this, I have to check the distance axis and check which number is correctly parallel to the X point. So I'm taking 1 meters. That means at this point, the body has completed 1 meters. So it's according to the distance axis. So the next is we can find the speed. So I am going to find the speed from point A to point B. The speed from these 2 points. So to find the speed, we have to find the value of the slope. So you can say like slope is equal to speed, and since we already know speed is equal to distance by time, then we can tell like slope is equal to distance by time. Now since distance is in the y-axis and time is in the x-axis, then you can tell like y-axis by x-axis. So this is the formula for the slope. So we have to find the y-axis by x-axis and you will find the value of the speed. So now the distance traveled at A, I am taking it as S1, and the distance traveled at B, I am taking it as S2. And the time at A is T1 and the time at B is T2. So now we have to find the value of the slope. So this AB, that this thing is the slope value. So to find that, we have to find y by x. Now y, this axis, which means that this part. So to find this part, we have to do S2 minus S1. Because from here, the value from here, and then you'll get the interval. So this distance interval is S2 minus S1. And here, the x-axis, we have to take it as T2 minus T1. So if we find T2 minus T1 and S2 minus S1, we can find it. So it's simply like y-axis by x-axis, S2 minus S1 by T2 minus T1. So this is what we have to find. So I'm mentioning that S2 is 4 meters, S1 is 2 meters, T1 is 2 seconds, and T2 is 6 seconds. So now we have to substitute it and then simplify. So which is 4 minus 2 by 6 minus 2, which is nothing but 1 by 2, or you can take it as 0.5 meter per second. So this is our speed. So by finding the value of slope, you can also find the value of the speed. So this is all about uniform speed time graph. So now let's move on to the next which is non-uniform speed. And let's check out how the distance time graph for that is. So there are 3 types of graphs under non-uniform speed. The first one is that the speed increases with respect to time. So I'm drawing the outline of the graph. Time here, distance here. So the shape of the speed when it is increasing with respect to time is pretty much a parabola. So this is the parabola shape. And you can see that it is a curved line. So the nature of motion here is non-uniform. So this is the graph for the speed when it increases with time. So the second one is that the speed decreases with respect to time. I'm drawing the graph, time, distance. So now it is also a curved line since it's a non-uniform motion, but you can see that there's a bend. So this bend indicates that the speed is decreasing with respect to time. So this is this graph for speed when it is decreasing with respect to time. The third one, the final one, is that when the body is at rest. So this is kind of complicated. So now the body while it is at rest, the distance time graph is parallel to the x-axis. This is because it is at rest. So there is no motion. That means if I've traveled 4 meters, then I'm staying in the same position because I'm at rest there only. And you can see that the time for t1, at t1 my distance is x, and for t2 my distance is also x. So that means that it's not moving, the motion is at rest. So that there's a constant distance. So these are the three graphs under non-uniform speed, and we have learned all about distance time graphs, and I hope you understood all about it. So we've learned about non-uniform speed, uniform speed under distance time graphs, and we learned how to find the nature of motion. We also learned to find the distance, and we have to find the speed, everything. So I hope you understood about distance time graphs. So thanks for watching. Don't forget to like, share and subscribe to SavvyNX. Stay tuned for more interesting videos. I'll see you all in my next video. Bye friends.